So we are on the stability. So for stability, we are going to check the overturning, buckling and the sliding. In the stability, we are going to prevent all these things, that is overturning, buckling and the sliding. And the next important thing when we are going to design the structure is the serviceability. So the strength, stability and the serviceability. So these all the things are the most important things that we have to check when we are going to design the structure. So for the structural design, the serviceability criteria will include stiffness, deflection, impermeability and the durability. So our structure should be safe enough for the stiffness, deflection, and it should also be impermeable. That is means water should not enter in that, as well as it should be durable enough. See, so these all the things will include in the serviceability. So we have to check strength, stability, and the serviceability when we are going to design any of the structure. Either it will be staircase, or either it is retaining wall, or either it is water tank. We have to check all the three criterias when we are going to design the structure. So strength, stability and the serviceability. These three are the important things we have to check when we are going to design the structure, and these are the main objective of the structural design. Nowadays we are going to use the softwares for the structural design. So can anybody let me know which are the two main important software that we are going to use for the designing and the detailing of the structure? Which are the softwares for the detailing and the design of the structure?
Stat Pro.
Huh? Statro and one more software is there that we are going to use for the structural design. Which one is that? Yeah, anyone? ETABS. Yes, the Statro and the ETABS, these are the two softwares that we are going to use for the structural design. But before going to design on the software, you should know all the criteria for the manual design. For that, the subject is being included in your syllabus. So you can't enter unless and until you will not know how to design the structure manually. You can't enter the values in the software. So manual design is also important before designing on the software. So for the reinforced concrete structure, first of all, what is included first is your planning phase. So the planning phase, first of all, for designing any of the structural design, planning is the most important thing that you have to do. So in planning, what you will do, planning will include your plan. That is the, it will include your architect or the planner to plan the layout of the structure. So the first thing that will include is your planning. In that you have to carry out the, that is being carried out by the architect or the structural engineer, and that will see the layout of the structure, as well as functional requirement, aesthetic requirement and the budgetary environment requirement. So these are the important things that will include in the planning phase. Then after planning you have to do the structural analysis and the design. So what will included in the structural analysis? Already we have studied SA1 and SA2. So you know what you are going to check in the structural analysis. You are going to check the slope and deflection of the building, bending moment, shear force, all the things that you are going to check in the structural analysis and the design. So structural analysis and the design is again the most important thing before starting the designing of the building. So selection of the most appropriate structural system to bring the architect concept into being. So if 2 to 3 designs are there, you have to select any one which is more appropriate for your as well as for you, as well as it will be suitable according to your budget. Then estimation of loads on the structure. You have to estimate all the loads that are being there on the structure. That is the dead load, live load, earthquake load, and the wind load. You have to estimate all the loads. That means you have to give the material, apply the loading, as well as you have to give the material property to the structure. After that, you need to do the structural analysis for estimation of the stresses. And you have to do the design of the actual proportion, that is for the actual size and the reinforcement, as well as you have to check the safety and the serviceability. So these all the things will be included in your structural design and analysis. And after doing all the structural design and analysis, you have to submit the drawing, whatever drawing reports that you have made, that you have to submit. But if your structure analysis is safe and is being service, if it satisfies the safety as well as the serviceability requirement, then you can proceed further. But if no, what you have to do, you have to revise the design. If it is being failing, if the errors are being coming, what you have to do, you have to revise it again. It means you have to do the design again, depending upon all the clauses of your IS code. So first one it will be your planning phase, and the next will include your structural analysis and the design phase. And what is exactly concrete and reinforcement steel? So plain concrete. What is plain concrete? Everyone knows what is plain concrete. Already you had studied in your BMCT. So the plain concrete will be included of mixing of cement, aggregate, water and admixture. So plain concrete will involve all these things, and it is generally prepared on the site itself. As well as we can use nowadays the ready mix concrete is also available. So you can use that also, or you can use the mix that is being prepared on the site. So for that, the compressive strength is very high. As you, I think everyone is knowing why the compressive strength of the concrete is high and the tensile strength is very low or negligible. Yes, can anybody let me know why the compressive strength for concrete is high and why the tensile strength is low? Yes, why the compressive strength for the concrete is high and the tensile strength is low? Yeah, anyone from you? Faraz, Fateh, all loads come on concrete. Yeah, okay. And what about others? So this is homework for all of you. So let me know tomorrow what is why the compressive strength for the concrete is high and the tensile strength is very low. I will ask you in tomorrow's lecture. Okay? Tell me the proper answer, proper technical answer for this one. Then reinforcement concrete, that is what is RCC, that is reinforced cement concrete, जिसका हम डिजाइन करने वाले हैं. What does RCC exactly mean? RCC is nothing but the steel embedded in the concrete. Now we are seen only plain concrete in the last slide, and in this slide it is reinforced cement concrete. So in reinforced cement concrete, It is the combination of the steel as well as concrete. As you can see in this particular diagram, the steel is being embedded in the concrete. So it is usually manufactured in factories under controlled conditions. As you can see over here, if there is yielding, if there is yielding in the steel bars, how the hairline cracks is being there in the concrete. So it can effectively take up the tension that will include it due to the flexural tension. So in this, there is the tension, and that is the different types of tension will be there. That is the flexural tension, direct tension, diagonal tension, and the environmental effect is also being there in this RCC, that is reinforced cement concrete. And because of the steel, अगर स्टील प्रोवाइड किया है तो it will also impart ductility to the material because of the steel. Uh, so the ductility is also one of the main important thing that is being there because of the steel is there in the RCC structure. अगर reinforcement concrete में steel आता है तो वो ductile behave करता है, and the steel compressive strength is more than the concrete. Obviously, the compressive strength for the steel will be more as compared to the plain concrete. Then the grade of the concrete. As you already know how many grades of concrete are there. So again, this is the table from the IS 456 2000 for 150 millimeter cube. There are three types of concrete. If the grade of the concrete is above M60, then it is high strength concrete. And if the grade of the concrete is between M25 to M55, it is the standard strength concrete. And if the grade is between M10 to M20, it is the normal strength concrete. So there are these three main important types of the concrete, that is depending upon the grade. So anyone is having any doubt up till here? Any query? If you are having any of the query, you can ask. Understood? RCC and the plain concrete, as well as this one is for the grade of the concrete. Okay. Okay. So as you can see, M20. So what is M? M is nothing but it refers to the mix, and 20 is nothing but the characteristic compressive strength that will be in Newton per mm square or the megapascal. So whatever grades we are going to see in the concrete, that will be for the M20, M10, M60. Already we are seeing the three main important types of the concrete. So it is like this. Uh, any doubts up till here? Okay. Again, we are going to see the different parameters that we are going to use for the designing detailing. That is nothing but the FCK. So what do you mean by the FCK? FCK is nothing but the characteristic strength. So again, when we are going to going to do the detailing and the design of any of the structure, we need to know the characteristic strength of the concrete. That is being referred by the FCK. So as you know, even if we collect the from the same mix, but there is the compressive strength that will be not be same for each and every block of the concrete. Compressive strength will be differing if even if we are collecting the cubes from the same type of mix. So what do you mean by exactly FCK? that is the characteristic strength. So as you can see over here, the proper definition for the characteristic strength, that is nothing but it is defined as the strength of material below which not more than 5% result are expected to fall. As you can see over here, in this graph, you have to check the compressive strength for minimum 28 days. Here there is specimen, and for specimen, here there is the mean strength. Already you have seen, already you have seen in this in your earlier semesters. So characteristic strength, this one is your characteristic strength. So characteristic strength is nothing but the strength of material below which not more than 5% result are expected to fall. So the coefficient of variation, the formula to calculate the coefficient of variation is your standard deviation upon mean strength. So as you can see over here, target mean strength is being calculated by FCK plus 1.65, as already these all the things is being there in your IS 456 2000. So it is subjected to considerable variation in the strength. FCK is your, as well as the variation in concrete is expressed in terms of the standard deviation or the coefficient of variation. As well as these are the different grades of the concrete, and depending upon the different grades of the concrete, the values of the standard deviation, that is denoted by the sigma. You have to take the values of the sigma for the different grades of the concrete. So for M10 and M15, the sigma is 3.5. For M20 and M25, the value of the standard deviation is 4. And if your concrete is greater than M30, the standard deviation is 5. If anybody wants to note down, you can note down the values for this. This is according to your IS code, that is for the IS 456 2000. These all the values you will need when you are going to do the design. So all are requested to note down this table for the characteristic strength FCK. And after completing, let me know so that we can proceed further. And if you are having any of the doubts or queries, you can ask. Everyone done? All the others had also completed? Okay. Now, modulus of elasticity of concrete, that is EC. Already everyone is familiar with this term, I think EC, that is modulus of elasticity of concrete. So EC will be your stress by strain. So as you can see from this particular graph also, strain is there on the x-axis and the stress is there on the y-axis. So for the concrete brittle material, it will be non-elastic and the non-linear. And only initial portion of the curve will be linear. As you can see over here, only initial portion is being linear, and then the curve is being there. And EC, the formula to calculate EC, that is modulus of elasticity of concrete, is stress by strain. And for short term elastic strain, it is instantaneous load is being there. That is EC is for the short term elastic strain. And for long term elastic strain, the creep and shrinkage is being there. That is being denoted by EC. तो अगर short term elastic strain हो रहा है तो at that time instantaneous load is being acting over there. And for long term elastic strain, effect creep and shrinkage is being acting over here, and it is denoted by ECE. So you can note down the formula to calculate modulus of elasticity EC. Again, it is also there in your IS code, that is IS 456-2000. But since, note down the formula, as we will require this formula when we are going to do the design. Okay, done. Should I proceed further? Then modulus of elasticity of concrete, that is EC. The formula to calculate EC, that is for the concrete, is 5000 under root of FCK. It is based upon your clause number 6.2.3.1. So the empirical formula to for static modulus, that is the EC for the short term strain, is calculated by using the formula 5000 under root of FCK. As you can see in this particular graph, the EC is being calculated by initial tangent modulus. This line is for the initial tangent modulus. Then tangent modulus is being there on a specified stress level, and this is your second modulus. From this, you need to calculate the EC, that is modulus of elasticity of concrete. For that, just you will require this formula, that is 5000 under root of FCK. It is in the clause number 6.2.3.1 of the IS 456-2000. Again, note down the formula to calculate the elasticity of concrete. These are the very basic things that you will require in each and every detailing and design. Each and every design. Okay. Then the tensile strength. Tensile strength. So 7 to 15% of the compressive strength is being there, and the remaining is the tensile strength test. So already tensile strength test are there. So that is the direct tension test. Already you have studied in the SOM how to perform the tensile test for the particular material, splitting test, and the flexural tension test. So this is again your 7 to 15% of the compressive strength. It is being the diagrammatically representation shows you the splitting test acting on the particular this one. Then FCR. FCR is again one of the important term that you need to calculate while doing the detailing of any of the structure. So FCR is nothing but the modulus of rupture. So And the formula to calculate FCR suggested by the code is 0.7 under root of FCK, as well as FCR also is being calculated by M by Z. So what is M over here and what is Z over here? Can anyone let me know? What is M over here indicate and Z? M is nothing but the bending moment and Z is your section modulus. So note down the formula to calculate the modulus of rupture, that is the FCR. Yes, Fateh, correct. These are the very basic things. From tomorrow onwards, we are going to do the design for the, first of all, we will start with the staircase. So tell your friends to attend the lecture from tomorrow. If they will miss any of the lecture, they will not understand. And be regular. Okay, completed? Okay. Then the creep. Creep is nothing but the theta. As you can see over here, this is the graph between time and the total strength. From that, you can calculate the creep coefficient. So, time dependent component of the total strength, that is nothing but the creep. As you can see in this diagram, on y-axis there is the total strength and on x-axis there is the time. So, this particular is your creep strain and the ultimate creep strain. As you can see over here, this is your ultimate creep strain and this is your instantaneous strain. From that, you need to calculate the creep coefficient. So the formula to calculate the creep coefficient, that is theta. The formula to calculate theta is your creep strain at time upon instantaneous strain. So note down the formula to calculate the creep, that is theta. All these are correlated with one another. So the formula to calculate theta is your creep strain at time upon instantaneous strain. Just note down the formula. No need to draw the graph and all these things because already this is there in your IS 456 2000. By today itself only download IS 456 2000. So it is better for you to refer from tomorrow. Okay, completed? Okay. Then creep. Creep is also depending upon the design, that is for the 7 days, 28 days and the for the 1 year. So the theta, the value for theta as per IS 456 2000 according to the clause number 6.2.5.1, the values for the theta will depending upon different days. That is for 7 days, the value for theta is 2.2. For 28 days, it is 1.6 and for 1 year, it is 1.1. And for effective modulus of elasticity, that is for ECE, we are seeing EC and ECE, that is for the long-term modulus. लॉन्ग टर्म मॉड्यूलस के लिए EC के लिए फॉर्मूला यू आर हैविंग EC upon 1 plus theta. So for that you will require the value for theta, and for value of theta you will require clause number 6.2.5.1. As you can see over here also, they had mentioned you this, the instantaneous recovery कब होता है and creep recovery कब होता है, as well as the residual creep strain. So same graph is there, but in this graph they mention the creep recovery depending upon the time. So just note down the formulas for the creep coefficient as well as the formula to calculate ECE, that is the effective modulus of elasticity. On the other side also completed. Anyone is having any query, any doubts? If you are having any of the doubts, you can ask. Okay. Then again, shrinkage strength. Just go, just on Google type IS code 4562000, you will get it and download from there. Or I will send you in your WhatsApp group. If you will not get, I will send in your WhatsApp group. So shrinkage. Again, shrinkage is the most important thing. So shrinkage is nothing but the when your concrete shrinks. जब भी आपका concrete hardened state में आता है due to the loss of moisture by the evaporation, that is nothing but the shrinkage. जब भी आपका concrete अगर एक कोई hardened state में आता है due to the loss of moisture, your concrete is being shrinking. Now, what do you mean by the dry shrinkage? Dry shrinkage is nothing but the reduction in the volume of the concrete. That is similar to the creep. That will induce time-dependent strength. Now, dry shrinkage is nothing but reduction in the volume of the concrete. जब भी आपका concrete का volume कम हो जाएगा, it is nothing but your dry shrinkage. And the differential shrinkage is due to the moisture of thermal gradient. या फिर ड्यू टू द अनसिमेट्रिकली प्लेस्ड रेनफोर्स स्टील इन द बीम. अगर आपका जो स्टील है जो वो रेनफोर्समेंट में अच्छे से प्लेस नहीं किया गया है, तो इट विल also result in the differential shrinkage. And due to the differential shrinkage, it will induce the internal stresses as well as the curvature and the deflection. So the shrinkage strength for the design expressed as a linear strain. This will again the value for the shrinkage strength. When you are going to design, you have to take the value for the shrinkage strength, and that value is 0.003 mm per mm according to the clause number 6.2.4.1 of the IS 456-2000. So just note down the value for the shrinkage strength according to the IS 456-2000. Okay. Written, noted. Okay. And durability. Uh, durability of the concrete. So durability of concrete is again most important parameter. We are running short of time. Last 2 minutes are there. So we will see this in the next lecture, as well as we are going to start the design of the staircase in the next lecture. That means tomorrow. So be remain present in tomorrow's lecture. And those who are not given the attendance, give your attendance in the chat box. And if you are having any of the query, you can ask. Any doubts, any queries, you can ask. Okay.